Now that we've talked a bit about how the Java Completable Futures API addresses the limitations with Java Futures, let's talk more methodically about how you can group together the methods in the Java Completable Futures API. And you'll see in a second why it's important to group things together, because otherwise you get drowned in a sea of methods. And the reason for that is that the entire Java Completable Futures framework resides in one public class with over 60 methods. So when you first are exposed to this class, if you look at the documentation, for example, it can be a bit daunting when you first look at it. Basically, what's happening here is this class, the Completable Future class, is implementing what's called the Facade Pattern. The Facade Pattern is a good old Gang of Four design pattern that says, let's provide a unified interface to a set of interfaces in a subsystem or a framework so that the subsystem or framework is easier to use. And if you were to look at the implementation of Completable Future, if you poke around in the source code, you'll see why, even though there's a lot of methods here, it's actually a tremendous simplification of what's actually taking place behind the scenes. Because if you look at the rest of the code that's in that giant class, your mind will explode because it's very, very, very complicated. And I think it's got something like a dozen or so nested classes, maybe more, and they're also very complicated. Super cool abstraction, but a little bit daunting when you're first exposed to it. So therefore, given this large number of methods, we'd like to have sort of a bird's eye view of how things work. And so this bird's eye view will give us a reductionist perspective that breaks things up into little chunks. This is a famous photo from one of the Apollo missions called Earthrise, and it was a view of Earth from the moon. It's always a really cool picture to kind of give you perspective on things in the universe. Some Completable Future features are very basic, and these are basically the ones that are the ones inherited from the Future interface, plus a few other little tiny enhancements that we'll talk about here in a minute. So those are, there's probably about, out of the 60 methods, there's probably about 7 or 8 of them, maybe, that are the basic methods. These are the ones that, as I said, implement the Future interface and do a little tiny bit more. But the bottom line is, if you only limited yourself to the basic features of Completable Futures, you would completely miss the purpose of why we have the rest of this wonderful framework. So they're there, but they're not very widely used. Probably the most widely used is the join method, and we'll talk more about that later. Other Completable Future methods are much more advanced and provide you with many more capabilities. So we've got factory methods, completion stage methods, arbitrary-arity methods, and exception methods. And we're going to spend the bulk of our time, of course, talking about those. Factory methods are kind of what you'd expect. They are used to start computations running asynchronously. So as you can see here, factory methods can initiate async, two-way, or one-way computations, and they don't require you to have to use threads explicitly. You can use explicit threads with Completable Futures, but it's very rare. So it's much better to use the factory methods, either supply async or run async. We'll talk about both of those in a bit. When you think back to the Reactive Programming Manifesto and the various capabilities and principles it espouses, factory methods help make programs more elastic by allowing us to leverage a pool of worker threads. So when you submit tasks to run asynchronously using supply async or run async, you're taking advantage of the underlying thread pool, thereby making your computations more elastic, which of course is one of the benefits of using the reactive programming model. The next group of methods, which as you can see are by far the bulk of them, almost probably 2/3 of them, are so-called completion stage methods. And they are used to chain together actions that perform result processing when asynchronous operations complete. And they also can be used for various types of composition. So you can say wait for 2 previous asynchronous operations to complete before doing something else. Wait for either or of 2 operations to complete before you do something else. There's a bunch of things along those lines. And these methods all come from the so-called completion stage interface. So there's an interface called completion stage, and Completable Future implements completion stage just like it implements the Future interface as well. Lots of really, really good stuff here. As you can see, the bulk of the stuff is in the completion stage methods. If you think back to the reactive programming principles, the completion stage methods help to make completable futures and completable future framework more responsive by not blocking caller code. So you have client programs that make calls, and by using these methods, these completion stage methods, the caller code doesn't need to block. You can go and run asynchronously without blocking the caller. Next group of methods are called arbitrary-arity methods. That's a funny name. Arity is just a means of saying how many parameters can be passed to a method. So we're all familiar with unary, which takes one parameter, or binary, which takes two, or trinary or ternary that takes three. So arbitrary-arity just means it can take an arbitrary number of parameters. And this is typically implemented by using something called the var_args feature, which allows you to have a variable-sized array of parameters that are passed to a given method. These methods can be used to process completable futures in bulk by combining multiple futures into a single future. And so the way this basically works is there's two methods here that are part of the arbitrary-arity method cluster of completable future methods. One is called any_of, which says, here's a bunch of completable futures. Whichever one finishes first, take that result. And the second one is all_of, which says all of these asynchronous computations must finish before the result is going to be triggered. So those are the two examples of arbitrary-arity methods, and they are really, really cool, as you'll see when we get a little further along. They also help to make programs more responsive by not blocking caller code, and you can do some amazing, amazing things with the arbitrary-arity methods. However, they are complicated to program, and therefore we typically wrap them in a very cool little helper class, which we call some kind of FutureCollector. You'll see that later as well. And then the final category are the exception methods. And the exception methods, as the name suggests, are used to decouple normal processing from exception processing. That's pretty much always what exception handling is about. It's a way of handling exceptional conditions at runtime. And this becomes particularly important when dealing with asynchronous processing, because inevitably, the thread that invokes the method in the first place is not the thread to handle the results, often. So as a consequence, if an exception happens, where does the exception get handled? It can't really get handled in the calling thread, because that thread is probably off doing something completely different by that point. So how do you handle exceptions? Well, you'll see how it gets done. And it's by using various methods like when complete and handle and exceptionally and so on. These particular capabilities help to make programs more resilient, yet another one of those mechanisms that's defined, those principles that's defined in the Reactive Manifesto, by handling erroneous computations gracefully in the right context, in the asynchronous context where the exceptional condition or the error condition occurred. And under the hood, if you poke around, and we will poke around later when we get into this, maybe not today, but certainly by Wednesday. If you poke around in the implementation, what you'll find is that all these methods are actually implemented using message passing. And so under the hood, there's a cool queuing framework that takes advantage of Java's thread pool mechanisms like the common fork join pool or fixed thread pool or a cache thread pool or whatever kind of thread pool you might want to design on your own. And so all these things are all done ultimately by message passing, even though you have a method-oriented facade that hides you from all the details of the message passing that goes on there. As we talked about before, message passing is a useful way of being able to decouple the code so that you can run things at different thread contexts. In this case, you don't care what thread it's running in. It can run in one thread, it can run in a different thread. Different parts of a pipeline could run in different threads. So it kind of makes the whole program more loosely coupled, which is very important for asynchronous stuff. We really want loose coupling and asynchrony to go hand in hand. So that's the end of the quick overview that groups the 60+ methods in the Completable Future API into basically 5 categories. Basic methods, the ones that come from Future, factory methods that make stuff, completion stage methods, which are by far the bulk of everything, arbitrary-arity methods, there's only 2 of those. Those can be used to wait for lots of things to finish running. And then finally, we have the exception methods, which handle problems and error conditions gracefully in an asynchronous context. Of course, we will talk about this stuff in more detail, so I'm just giving you the high-level view So as we start diving into the details, you can keep track of what we're talking about and how it fits into the bigger picture.